Hello, Namaste. Welcome to this channel Chemistry Made Easy by Dr. ARM. Today we will see the effect of presence of lone pairs and bond pairs on the shape of molecule. So for this purpose we will see first the magnitude of repulsion because of the presence of various types of electron pairs. When there are two electron pairs, that is lone pairs, are lying close to each other, the magnitude of repulsion is maximum. When there is one lone pair and one bond pair close to each other, the magnitude of repulsion is relatively less. Again, when the two bond pairs are close to each other, the magnitude of repulsion is again less. So in some examples we will see this structure. So for example, NH3, the steric number is 3 bond pairs plus 1 lone pair, so that is 4. So here we will find that there is a lone pair. Now the nitrogen is at the center and there are lone pair, this hydrogen. So presence of this lone pair push away all these bond pairs, as a result of which the bond pairs are coming closer and the expected distance, that is bond angle, is expected to be 109 degrees 35 minutes, and because of this repulsion it gets reduced to 106.5 degrees, and shape of this molecule is tetrahedral. So presence of this lone pair shows reduction of bond angle by some degrees. Now we will see the second molecule, that is water. Here steric number is 2 bond pairs plus lone pairs 2, so it makes 4, and the shape of the molecule is tetrahedral, where oxygen is at the center. These are 2 bonds of oxygen with hydrogen, and there are these 2 lone pairs. So the shape of this molecule we can also draw in this way. These are orbitals. So these are pushing away, these are lone pairs. So these are having effect on these bond pairs. So these will repel each other. Further, this lone pair will repel this, and this lone pair will repel this. Means both lone pairs will repel these bond pairs away. As a result of these, the 2 bond pairs are coming closer, and this gives bond angle 104.5 degrees. So the shape of this molecule is, the structure is tetrahedral, and we say the shape is angular, like this HOH, that is angular shape. Now next structure of example is the SF4 molecule, that is SF4. It has steric number 4 plus bond pairs 4 plus lone pairs 1, so it gives 5, and the structure of this SF4 is like this. Sulfur is at the center, lone pair is present in the XY plane, so 2 fluorines are lying in XY plane, and 2 fluorines are lying away from XY plane. So this is lone pair. So here you will find that this lone pair will push away, so that we can mark the shape in this way, that is XY plane. So this lone pair push away these bond pairs. So these bond pairs are reduced to some degree. We are expecting the trigonal planar structure where the bond angle is 120, but it is reduced from 120 to 101.6 degrees. 101.6 degrees. Whereas this distance, FSM distance, that is bond angle, is 86.2 degrees. And structure of this molecule is trigonal bipyramidal. So you will see the effect of this lone pair, that this bond angle is reduced from 90 degrees to 86.2. This bond angle is reduced from 120 degrees to 101.6 degrees. Now we will see other examples where we will have the ClF3, then BrF3 and XeF2. So here you will have steric number 3 fluorines, means bond pairs 3 plus lone pairs 2, making 5. In this case also same, that is steric number 3 plus 2 is equal to 5. Here also steric number is 2 plus 3 is equal to 5. Now the structure is ClF3. So you will have the lone pairs and these you can mark this XY plane in this way, and there are two lone pairs. So there is strong repulsion between these lone pairs. There is strong repulsion. So these are moving away. As a result of these, two lone pairs will have effect on this fluorine, but this fluorine is at equal distance and far away from these pairs. But these fluorines which are perpendicular, which are expected to be perpendicular to this plane, are moving slightly away. So this bond angle is reduced from 90 degrees to 86.2 degrees. Or we can say the ClF distance angle is 173 degrees. Both is same. Now in case of this BrF3, same case, there are two lone pairs. There is one fluorine in this plane. Two fluorines have slightly moved away. The plane XY is marked in this way. The bond angle is reduced from 90 degrees to 86.2 degrees. Shape of the molecule is TBP in both cases, trigonal bipyramidal. But here, in case of XeF2, there are three lone pairs and two bond these are shown in the XY plane. So three lone pairs are shown in XY plane. So they have no effect on these bond pairs. So the FXCF bond distance remains 180 degrees. So the molecule is linear in shape, but the structure is trigonal bipyramidal. So this information we will stop here, and the next part of this will be continued in the next lecture. Till then, goodbye. Keep watching this video and press the like button and bell icon and subscribe to this channel. Thank you very much.